All right, so let's talk about the isosceles and the equilateral triangle. This says an isosceles triangle is a triangle in which at least two of the sides are equal in length. An isosceles triangle is a triangle in which at least two of the sides are equal in length. What that means is that a triangle in which three of the sides are equal is really still considered to be an isosceles triangle. So we'll get into that a little bit. So an isosceles triangle is a triangle in which at least two of the sides are equal in length. An equilateral triangle is a triangle in which all three sides are equal in length. So the isosceles triangle, at least two of the sides are equal. The equilateral triangle is a triangle in which all three sides are equal in length. Then the next thing now to say is this, that the equilateral triangle is a special type of isosceles triangle. The equilateral triangle is a special type of isosceles triangle. What does that mean? It means, therefore, that what I'm going to say to you about the equilateral triangle applies also to the isosceles triangle. Here it is. The two equal sides of the isosceles triangle meet at the apex. So in mathematics, we identify that two sides are equal by putting strokes on them. So those two strokes are telling me that those two sides are equal in length. If you have a triangle in which two of the sides are equal, that triangle is an isosceles triangle. Now, for an isosceles triangle, so the two equal sides of the isosceles triangle meet at the apex. Opposite from the apex is the base. Opposite means on the other side. The two base angles of an isosceles triangle are equal. So the two equal sides of an isosceles triangle meet at the apex. Opposite from the apex is the base. The two base angles of an isosceles triangle are equal. Continuing. Now, this is what you need to know. If a line is drawn from the apex of the isosceles triangle to the midpoint of the base, that line is called the height or the altitude. So a line is drawn from the apex to the middle of the base. Middle of the base means that it divides the base into two equal halves. Now, the height, so that line is called the height or altitude. The height bisects the angle at the apex, so it divides this angle here into two equal halves. It bisects the angle at the what? Apex. And it divides the triangle into two congruent or identical right angle triangle. So I'll say that again. If a line is drawn from the apex of the isosceles triangle to the midpoint of the base means that it cuts the base into two equal halves. That line is called the height or altitude of the triangle. Now the height or altitude bisects the angle at the apex. So it bisects the angle at the apex. Let's call it alpha. And everybody should know that these two angles were already equal. This is theta, this is theta. If this is 90, this is 90. So it bisects the angle at the what? Sorry, the height bisects the angle at the apex and it meets the base at right angle. So it meets the base at right angle. This means that it divides the triangle into two identical right angle triangle. So the height or altitude of the isosceles triangle, and by extension, the equilateral triangle, divides the triangle into two identical right angle triangles. Now, with that in mind, I want you to try this example. I'll give you a couple of minutes, and at the end of the couple of minutes, I will do the question. All right, so let's do example 2. In example 2, we're asked to calculate the height of the isosceles triangle below. All right, so here's what we know. It's an isosceles triangle. We know that the height is drawn from the apex to the base, to the middle of the base. So it divides the base into two equal halves. It means that this side is 8 centimeters and this side is 8 centimeters. And that the angle here is a right angle, and this is the height. This is the apex. And down here is the base. How do I know that up there is the apex? Because I told you that the two equal sides of the isosceles triangle meet at the apex, and the side that is opposite from the apex is the base. And if a line is drawn from the apex to the middle of the base, that line bisects the angle at the apex, and it meets the base at right angles. It divides the isosceles triangle into two identical right angle triangles. So what I really have working with is this. This is 8 centimeters here. This is 8 centimeters, right angle. This is 17 centimeters, and this is h. This is a reason for applying Pythagoras Theorem. So once I know two sides of a right angle triangle, and I wish to find the length of the third side, I'm going to apply Pythagoras Theorem. The Pythagoras Theorem formula is c squared is equal to a squared plus b squared. And in that formula, c is the hypotenuse and a and b are the other two sides. The hypotenuse is in front of the right angle. So 17 is the hypotenuse, 1, 7. The other two sides are 8. So it's 17 square, 8 square, plus h square, where h is the height. 289 is equal to 64 plus h square. Positive 64 goes over and become negative. So h square is equal to 225. The opposite of square is square root. So h is equal to 15 centimeters. So the height of the isosceles triangle in example 2, h is equal to 15 centimeters. And that is the end, ladies and gentlemen, of Pythagoras Theorem.